So the first, whatever he has given, remainder theorem. See, the theorem is not required for arithmetic, because arithmetic we know that. Okay, so he's dividing 23 by 4. This is our notation. So we do 23 and we write the 4 here, and 4 5s are 20, and we have this. We know that this is a remainder, we know that this is a quotient, and we know that this is a divisor. So he's telling you multiply this and this. Are we multiplying the same thing? Yeah, so we are taking the quotient, which is 5, okay, and you are multiplying with the divisor, whatever is there, this particular thing. Okay, so after that you are adding this remainder. Okay, yeah, you are adding that remainder. So if the remainder is 0, if r equal to 0, that means 4 divides whatever 4 divides, right, or divides this number completely. That means no remainder, it is a factor. In such a case, 4 no, not 23 right now, because if it is 20, for example, let us take 20 divided by 4, then we have 20, 4, 5 times 20, so you got 0. So applying the same thing, this is your Q and this is R. Okay, so here R equals to 0. That's why 4 is a factor. 4 is a factor of this 20. Correct, right? So this is what the arithmetic is about. Now he's talking about how do we apply the same thing here. Okay, so if I have, I'm just taking this to here. Okay, if I have f of x meaning it is a polynomial in x. Okay, and you are dividing that with something, and he's telling it could be x minus a. It's an example. It could be x plus a also, it could be x plus b or whatever. Okay, so something you are dividing, then we rewrite exactly the same way. You have f of x and you do like that, x minus a, and you do, we write it because we don't know what it is, we write as a q, and we'll get something here, something we will here. Okay, I'm multiplying this and this, so after that you get a remainder. So we are doing this polynomial division. Okay, and that's how we write it. And therefore what he says is that the way you have written q into 4 here, we write q into x minus a. I'll pan it and then show you. So we are writing it as q into for this top part. Okay, or shall I erase this part or leave it? I'll put it in next page, that's a better thing. Okay, yeah, yeah. So q into, yeah, quotient, always take the first one, and then the divisor. This is a divisor, yeah, plus remainder. That will give you the actual number, numerator. I would call it as a numerator or the number. So this you could call it as a divisor or a denominator, whatever. Okay, so this is applicable even for the polynomials. That's what is he's telling. This we are aware, polynomials division. Okay, the theorem has not started yet. What the theorem says is that, can I have a shortcut method, to find r? That is the question. So yes, it is possible. So you have f of x. In this you substitute f of a. When do we substitute? When you substitute a, whatever you get the answer, right? That's a remainder. So f of a is the remainder. So when do we do f of a? If the divisor is x minus a. If the divisor is x plus a, then I have to do f of minus a. Got it, right? So how do I get this a or minus a? Simple. So whatever is the divisor, for example, I got x minus a and f of x. You equate this fellow to 0. X minus a equal to 0, you get x equal to a. If it is x plus a, then you will say x plus a equal to 0, then you get x equal to minus a. Depends, like whatever is the denominator, you equate to 0 to see what is to be substituted. So this is the shortcut method is nothing but the remainder theorem. Anything better, or still your same confusion? Or I will give an example.
So, like when you're in the f of x is equal to q into x minus a plus r. So if you take f of x as f of a,
Yeah.
then after substitute all x as a.
Correct.
So it'll be q into a minus a.
No. Yeah, exactly. Good. It will cancel. Correct.
So b is q plus r.
No, q into x minus a is just r. So you will get f of a equal to r. Okay. So we'll do an example now. Okay. So example, we want to see use the remainder theorem. Use the remainder theorem and find the remainder of whatever I am going to give, say x cube plus x plus 20, okay, divided by shall I take a simple example first? X minus 2. So I want to get remainder. So what is that? Our f of x here, you have to write these things. F of x is x cube plus x plus 20. Okay, so x minus a is nothing but x minus 2, which means a equal to 2. Right? This is your x minus a. So you are substituting f of a. That means f of 2. 2 cube plus 2 plus 20. So you get 8 plus 2 plus 20. This is equal to 30. So this, yeah. So now we will say remainder equals to 30 using this theorem. Otherwise, what we would have done? We would have done the long division. Yeah. So this is a shortcut. Obviously, theorem is helping you to avoid all that, the long division, and giving you the answer 30. So if you are not sure, then do the long division and let's see whether we get it or not. X plus 20. So I'll just separate it out. Okay. So I am dividing this now with the x minus 2. So you get x squared times, so that's x cube, minus 2x squared. So minus 2x squared I wrote outside. So you get this minus, this is plus. So x cube gets cancelled. So this becomes 2x squared plus x plus 20. So I'll put plus 2x. So I get 2x squared minus 2x. Okay. So you got minus 2x. Minus 2x or minus 4x? Minus 4x. Minus 4x. So this 2x square gets cancelled. So you got 5x plus 20. So I make it as a 5. So you got 5x minus 10. So minus plus. So you get 30. Right? It's the same answer. Yeah. So this is what the remainder theorem about. Okay. So yeah. You want to ask another question, or shall I explain the factor theorem?
I'll try one more.
Yeah, yeah. So you want me to give a question, or you have a question ready?
Can you give?
Yeah, sure. Yeah, sure. So f of x is x to the power of 4 minus x cubed plus 2x plus 5, and divide this with x minus 5 and find the remainder using remainder theorem. So this is a question. Okay. Yeah.